Welcome to lecture number 6 on measurement of pressure. In my last lecture we have studied atmospheric pressure, then pressure references, then gauge pressure, vacuum pressure, and absolute pressure points we have covered in my last lecture. Now today we are going to start measurement of pressure, lecture number 6 on manometers and mechanical gauges. The manometer of two types, simple manometers and differential manometers. Simple manometers are again categorized in three, namely the piezometer, U-tube manometer and micromanometer. Whereas the differential manometers, they are categorized under four types. Number 1, two piezometers. Number 2, U-tube upright manometer. Number 3, inverted type U-tube manometer. And number 4 is differential micromanometer. Again, we are also studying the two types of mechanical gauges, namely Budden's type mechanical gauge and diaphragm type mechanical gauge in today's lecture series. Today we are going to start with lecture number 6 on fluid properties, pressure measurement by manometers and the mechanical gauges. The manometers are of two types, simple manometers and differential manometers. The simple manometers are those whose one end is connected to the pressure point and another end is exposed to the atmosphere. And the differential manometers are those which measures the difference between the two pressure points in a fluid contained in a pipe or in vessel. Simple manometers whose one end is connected to the gauge point and another end is free to the atmosphere. Simple manometers are of three types: piezometer, U-tube manometer and single column manometer. In piezometer, the piezometer is used to measure the static pressure of a liquid flowing in any section of a pipe. The height h to which the liquid rises in the tube represents the pressure head. Already we have talked about the pressure head, that is h is equal to P by W at the level. So where the tube is connected to the pipe. So here PA is equal to WH. Already we have proved this in my last lecture. So H is equal to P by W. PA is equal to W into H and H is equal to PA by W. The pressure head at H, let us say at the center of the pipe, let us say this is pressure PA and height is H. So PA is equal to W into H. So if you multiply by this height H by specific weight of water, so you will get the pressure at A in terms of Newton per meter square. If we take 9810 Newton per meter cube as specific weight of the water. So this way we can calculate the pressure by using piezometer. Then next one is the U-tube manometer. U-tube manometer, the pressure head at E and pressure head at F is almost equal to same, and we want to measure the pressure Px. Okay, so let us find out the pressure at Px. So Px by W is the pressure at this particular point. Then let us go down Y1. When we go down, we take positive sign here. So Y1 into Y1 multiplied by respective specific gravity contained in this pipe Px, where we have written Px. So Px by W plus Y1 into specific gravity of flowing fluid is equal to pressure at E is equal to F is equal to S. S means the manometric liquid, specific gravity of manometric liquid into Y2. Why Y2? Because the pressure at E is equal to pressure at F. So manometric equation will become Px by W plus Y1 is equal to S into Y2. Okay, so Px by W plus Y1, if this is water here, so we took here 1, but if it is oil, then we have to take the this Y1 has to be multiplied by specific gravity of oil. So Px by W plus Y1 is equal to SY2. So Px by W is equal to SY2 minus Y1. So let us say the combination of mercury and water here, and we want to measure the pressure at X. So Px by W is equal to 13.6. Because why 13.6? Because it contains this as mercury. So 13.6 into Y2 minus Y1 into 1. So equation will become, in that case, Px by W is equal to 13.6 into Y2. In general pressure head at X in terms of the column of liquid in the pipe, so PS by W is equal to SY2 minus Y1. So this way we can write the manometric equation. S is equal to specific gravity of the measuring liquid with respect to liquid in the pipe. If pipe contains specific gravity of different type of fluid, so there we will have to multiply by that respective specific gravity. I hope you understand. Then single column micromanometer. Here this is a pipe. The manometer is connected to the pipe and we want to measure the pressure at point A. And one end is connected to the reservoir. One end is connected to the reservoir and another end is exposed to the atmosphere. So let us say there is a small pressure in the reservoir and it is deflected by delta Y. Subsequently what will happen? The height will rise by H2 in from B to D. When manometric liquid at the reservoir stands at OO level, means this level, okay, at this level it is stands OO level, not connected to the container. So Y into S1, Y into this liquid specific gravity is S1 is equal to H1, means this height H1 into S2, that is manometric liquid. Let us say it is mercury. So let us say this is equation number 1. Now when it is connected to the pipe, then there is a drop of manometric liquid surface in the reservoir by distance delta Y. So let us say delta Y is the drop here in the reservoir. So consequently there will be height H2 raised above B. So there will rise by H2. If capital A is the cross-sectional area of this reservoir and small a is the cross-sectional area of the tube, this tube, okay, then equation will become capital A, area of the reservoir, multiplied by deflection, small deflection or the small drop delta Y is equal to A, area of the tube, cross-sectional area of the tube into H2. So this becomes equation number 2. If PA is the intensity of pressure at point A and W is the specific weight of water, starting from D, gauge equation in terms of water is obtained as, let us say 0, because why it is 0? Because it is exposed to the atmosphere, so it is 0. Going down, when we are going down, we always take plus sign. So plus H2 plus H1 plus delta Y. So H2 plus H1 plus delta Y, let us say in this column. So this is manometric liquid. So all these things H2, H1 and delta Y has to be multiplied by manometric liquid, that is S2. Okay. Then we are already here at CC the pressure is same, then we are going up. When we are going up we take negative sign. So minus delta Y into this liquid having specific gravity S1 minus Y into S1 minus PA by W is equal to 0. You can write it, or you can write this way: 0 plus H2 plus H1 plus delta Y into S2, whole thing into S2, minus delta Y into S1 minus Y into S1 is equal to PA by W. So this is equation number 3. Now introducing equation number 1 and equation number 2. In equation number 3, what will happen here? PA by W is equal to H2 into S2 plus S2 minus S1 into small a upon capital A. Then by making the reservoir of large cross-sectional area, this ratio, that is A upon A, small a upon A, can be made 0. So the equation will becomes PA by W is equal to H2 S2. This way also you can write the equation. It will reduces to PA by W is equal to H2 into S2. This way also you can write the equation. So same thing, same micromanometer, but here angle of inclination is sin theta. Same equation will be here, PA by W H2 sin theta, because why? H2 is not vertical now, so it is inclined here. H2 into sin theta into S2. So this equation will become like this way: PA by W is equal to H2 into sin theta upon S2. Rest of the things are same, only thing you have to take H2 S2 sin theta, because this component we have to take as sin theta. Okay, nothing is there. How will you measure the negative pressure in the pipe? it was a university question asked once upon a time. So for measuring negative pressure of a large magnitude, the manometric liquid having higher specific gravity is employed. First thing is that when we want to measure the negative pressure, then we'll have to use the higher specific gravity manometric liquid. Let us say specific gravity of flowing liquid is A is S1 with respect to, and specific gravity of flowing manometer is S2. The equation arrangement is Pa by W into S1. So Pa by W into S1. So this is S1 is the flowing liquid is equal to Z minus Y1 into S2 upon S1. So in terms of water, it will be Pa by W is equal to Z S1 minus Y S2. Let us say this is another arrangement here. So Pa by W into S1 is equal to Z minus Y S2 upon S1. So this way also you can use the equation for measuring the negative pressure in the pipe. Now YouTube differential manometer, A and B, these are the two pressure points. Then manometric liquid difference is X and this is Y here. So Y is the manometric flowing column height in that is up to A and C, and Y plus X, it is Y plus X, and at B it is Y from B to D. So commencing from point A, okay, let us commence, we will write the equation directly here. Commencing from point A, where the pressure Pa we have to measure, so Pa by W going down Y into S1 plus X into S1. So Y plus X S1. So Pa by W plus Y plus X S1. Now pressure at C is equal to pressure at C dash. Okay. Then from C dash we will go up. Then increase in elevation and decrease in the pressure head. Pressure head at B is equal to Pa by W plus Y plus X S1 minus X, okay, into S2, minus X into S2, and minus Y into S2 is equal to PB by W, or you can write Pa by W plus Y plus X into S1 minus X S2 going up, then Y minus Y S1 going again up, minus PB by W is equal to 0. So Pa by W minus PB by W is equal to X into S2 minus S1. In case of mercury and water, let us say the example of mercury and water will very frequently we will use in fluid mechanics 1, 2. So Pa by W, the pressure head at inlet, and PB by W, pressure head at the throat. Let us take the case of the venturimeter, and H dash is the difference in height, manometric level difference. Okay, H dash. Pa by W minus PB by W is equal to H dash into S2 minus S1. So here S2 is 13.6 and S1 is 1. So Pa by W minus PB by W is equal to H dash or X into 12.6 times 12.6 times. So X into 12.6. So Pa by W minus PB by W is equal to 12.6 H dash. This will be our equation in when we measure the pressure difference at inlet and throat while dealing with the venturimeter, orifice meter, and all these pressure difference measurements. Pa by W minus PB by W is equal to H dash into S2 upon S1 minus 1. This is the manometric equation for different YouTube upright differential manometer. Now if pipe A and B are at different elevations, let us say it is separated by having elevation Z here. Pa by W, okay, Pa by W plus going down Z plus Y plus X into S1, then going up because at this point C and C dash pressure is same, then going up X into S2 because manometer is this flowing liquid, minus Y into S3. Here in this case the pipe B, the liquid is different, so we have to multiply it by YS3 is equal to PB by W. So PA by W minus PB by W is equal to X into S2 minus S1 plus y into S3 minus S1 minus ZS1. So this is the manometric equation for such kind of or such type of arrangement. Inverted U-tube manometer, it is consisted of the glass tube, U-tube inverted. Air cock is fitted, sometimes it is used also air or it is the flowing liquid is water, and the this manometric liquid is toluene and the flowing liquid is water. This way also you can consider. So inverted U-tube manometer is consisted of the glass tube, U shape. Inverted air cock is provided at the top of the inverted U-tube manometer, which facilitates the raising the liquid columns to a suitable level in the both the limbs of the drying out of the portion, the compressed air. It is very sensitive and it is measured when we want precision in pressure difference. So at that time this inverted U-tube differential manometers are employed. So again PA and PB are the two pressure intensities. Inverted U-tube manometer is connected between A and B here. Then corresponding these pressure intensities of the liquid rise above the point A and above the point B, that is up to C and D in the two limbs of the manometers. W is the specific weight of water, S is the specific gravity of liquid. Sometimes it is used the lighter liquid, toluene is also employed here, or sometimes air also is employed here. So then commencing from A, then we are going up. So when we are going up, we have to take negative sign here. So PA by W minus Y into S1. Okay. Then pressure at C is equal to pressure at C dash. Then we are coming down. PA by W minus Y into S1 going up. Then plus Y into H. Y minus H into S1 is equal to PA by W, because at this point this is PA by W. So Y minus H, yes, into S1 is equal to PB by W. So and when it is the water and air, so commencing from A, PA by W minus Y into S1, okay, then pressure at C is equal to pressure at C dash, then PA by W minus Y into S1 plus H dash into S2. So PA by W minus Y into S1 plus H dash S2 going down plus Y minus H S1, Y minus H into S1 is equal to PB by W. So PA by W minus PB by W is equal to H dash S1 minus S2. So let us say S1 is water here and S2 is toluene. Let us say it is 0.75. So 1 minus 0.75 into H dash will be the pressure difference between these 2 points. Pressure head difference 2 points. So this is micromanometers. A and B are the pipes. Then these are the two reservoirs and S1 is the manometric liquid. So PA by W plus Y1 plus delta Y into S3. Y1 plus delta Y, okay, into S3, because this flowing liquid is S3. So Y1 plus delta Y into S3. Then plus Y2 minus delta Y. Now we have to subtract this delta Y plus X2 by 2 into S2 minus, now came here, so minus X into S1 minus Y2 minus X2 by 2 plus delta Y into S2, okay, minus Y1 minus delta Y into S3 is equal to PB by W. Now A into delta Y is equal to A into X by 2. Okay, so PA by W minus PB by W is equal to X into S1 minus S2 into 1 minus A upon A minus S3 into A upon A, making this reservoir of large area. A by A can be ignored here. So equation becomes PA by W minus PB by W is equal to X into S1. This way also you can do it. Now there are two mechanical gauges commonly employed are Burden pressure gauge and diaphragm type pressure gauge. So Burden type pressure gauge, it is consisted of the metallic tube elliptical in cross section closed at one end A and NB is being fitted to the gauge point. Let us say tire pressure of any petrol pump. So when the pressure is measured by using the pinion sector, this arrangement, so this deflector or this pointer gets activated, and small elastic deformation on the tube is communicated to the pointer as an amplified manner, and the pointer moves over the graduated scale. So petrol pump, or they are commonly, you will find this device at the petrol pump or puncture wala and likewise shop. So here we can measure the pressure. So when we say 30 का हवा भरने का, 28 का हवा भरने का, so that represents the 30 pounds per inch square और 28 pounds per inch square. सामने का 30 और पीछे का 35 अगर है तो 35 it is pounds per inch square, and rear wheel is 35 pounds per inch square, because still the petrol pump wala, they are using the British type of system. If you say 1.1 kg per centimeter square, they may not understand it. But if you say 35 and 30, they will very well understand. So this is the burden type mechanical gauges. Now nowadays there are electronic gauges are also employed to measure the pressure measure devices. Another type of it is the diaphragm pressure gauge. It is similar to the burden gauge. Instead of burden tube, a corrugated diaphragm is provided where the device is fitted the diaphragm and will undergo the elastic deformation, and this deformation is communicated to the pointer in amplified manner, and the pointer moves on a graduated scale. So this is the diaphragm type mechanical gauge. So earlier we used the mechanical gauges, burden tube diaphragm and the diaphragm type mechanical gauges, but nowadays they are replaced by the electronic devices or electronic pressure measurement devices. In most of the petrol pump I found these are replaced by the electronic pressure measurement devices. So here they are having sensors. Once you reach the some 30 or 35, so they will give the beep sound, and you can understand that the tire pressure is sufficient now, and the procedure is closed there itself. So these are the pressure measurement devices that we have studied today. So friends, today we have studied the measurement of pressure devices, manometers, simple manometers, differential manometers. Simple manometers we studied piezometer, simple U-tube manometer and micromanometer. In differential manometers we studied the two piezometer, that is two piezometer means two piezometers are connected to two pressure points, and let us say H1 and H2, they are the different elevations. So H1 minus H2 will give the difference between the two pressure points. PA by W minus PP by W is equal to H1 minus H2. Let us say in venturimeter case, let us say this is H1 is the rise at inlet and H2 is the rise at throat. So the difference between inlet and the throat will be H1 minus H2. So PA by W minus PB by W is equal to H1 minus H1 minus H2, or PA by W minus PB by W is equal to HA upon HB. Also you can write, or P1 by W minus P2 by W is equal to H1 minus H2. Also you can write it. And then we studied the differential upright manometers. So that is PA by W minus PB by W is equal to H dash into S2 upon S1 minus 1. So common example is PA by W minus PB by W is H dash into 13.6 mercury upon 1, that is water, minus 1. So PA by W minus PB by W is equal to 12.6 times of H dash. Once you know the difference, manometric level difference H dash as H dash, just multiplied by 12.6, you will get the pressure difference between the 2 points, that is PA by at A and at B. Let us say at A is at inlet and B is at throat. So PA by W minus PB by W is equal to H dash into S2 upon S1 minus 1, that is 12.6 times of H dash. Then we have also studied the differential micromanometers and differential inverted U-tube manometer. Inverted U-tube manometer are very sensitive, and when we want to know the precision in level difference or precision in pressure difference, then that case the inverted U-tube manometers are used. For example, in medical colleges or medical hospitals. So these inverted U-tube manometers where the precision is required, so that time the inverted U-tube manometers are employed. Then we also studied the mechanical gauges, the two type of mechanical gauges, button type of mechanical gauge and diaphragm type mechanical gauge. So all these aspects we have studied today, and I will conclude my lecture here itself. Please do subscribe, please do like, and please do comment in case if you desire in comment section. Thank you.